Okay guys, so we are going to be taking Cornell notes on an introduction to graphing just to give you some background on what you're going to be doing tonight, and it kind of connects with the activity we did. 0.1 meaning Unit 0, Lesson 1, Introduction to Graphing, and your essential question is, in what ways can I describe a graph accurately and with detail? So I'm just going to give you some very brief notes. We're setting it up Cornell note style. So right now we're just going to be doing some terms. So what I want you guys to do, on the left side, I'm going to define always increasing, always decreasing. And I'm going to give you some examples. And constant. Now, something I want you guys to note. Please, please, please. So everybody look up here for me really quick. Where you see these graphs, we're just going to do little sketches. So you can just draw an X and Y axis. You don't have to draw the little grid lines, okay? Where the numbers are doesn't really matter for these notes. We're just going to do a little sketch. So don't freak out. Okay, so always increasing, always decreasing. Always increasing is when a graph is either going up, increasing, or going down, decreasing forever from left to right. Why left to right? Which way do we read when you're reading words? Left to right. So we read graphs the same way, okay? So if your graph is going up from left to right, that is called always increasing. And it's always going up from left to right. If your graph is going down from left to right, it is called decreasing. And then we also have the definition of a constant graph. A constant graph is when a graph stays at the same level forever and ever from left to right. Okay? So constant is when it stays at the same level. And I actually had one group that did sort those constant graphs separately. And I'm going to show you the examples on the cards as well. So what I would like you to do is make sure you have this written. Draw 3 X and Y axes for me. And then I'm going to give you an example of each one. So an always increasing example that I'm going to do is just a straight line. From left to right, it goes up. Okay, so that one is increasing. So let's write that underneath. Okay. So then let's do a decreasing that's not a straight line, so that way we have an example of that. I'm going to do one of those L-shaped ones. So remember, it means it's going down from left to right. So let's make it look like that. So that one is always decreasing because it's still getting smaller and smaller, right? So that's decreasing. And then a constant, let's do it up here, straight line. Okay. Make sense so far? Okay. Thumbs up, we're great. Thumbs down. Mrs. Dodson, you need to explain it again. If you're in the middle, I think I got it. I'm going to need some practice though. Okay, perfect. Okay, so we also have what is called an absolute minimum or an absolute maximum. And the definition for each of those is the same. It's just that one is a lowest point and one is a highest point. So the absolute minimum and maximum are when a graph has only one point. And I capitalize that and I'm going to put a box around it. It's super important. That is considered either the lowest, which makes it the minimum, or the highest point, which is what makes it the maximum. Okay? So absolute means there's only one. And then we're going to do an example of each of those. So there are only two types of graph that you guys looked at today that could have an absolute minimum or an absolute maximum. One of those is those curvy U-shaped ones. So if I am looking at an absolute minimum, that means that it has a lowest point. So the graph will look like this. Why is this considered a minimum? Any ideas?
Because the lowest point is, there's only one lowest point.
Yeah, look at this point right here, guys. I missed it just a little bit. But do you guys see this point? Is there any points on the graph that go below that? So that is called the absolute minimum. Okay. On a line, there's no absolute minimum because it keeps going on forever and ever and ever, right? So there's only one place that is considered the minimum. So what do you think a graph with an absolute maximum is going to look like? Yep, the same thing but flipped over. Those V-shaped ones that look like this can also have a minimum or a maximum because they are increasing then decreasing. So I'm going to do a V-shaped one for this one. Okay, so this point right here is your maximum. Does that make sense? So that's talking about the Y value. Okay, so we have vertical symmetry and horizontal symmetry. How many of you remember in kindergarten or preschool when you used to make the butterfly and you would paint one side and then fold it in half and then it's the same on the other side? Kind of? Or do you know what I'm talking about? Okay, that's called symmetry, meaning it's exactly the same on one side as the other. So vertical symmetry happens when you fold a graph vertically, which is up and down the middle, and it's the same on both sides of the fold. So an example of vertical symmetry would be those V or those U-shaped graphs that are the same if you folded it vertically. So for example, that guy. It has vertical symmetry because if I were to fold it right down the middle vertically, it's the same on both sides, right? Like a mirror. So that's vertical symmetry. So what do you think horizontal symmetry is? If you folded it horizontally and it's the same side. So any ideas of how we could get something to be horizontally symmetric? How could I make this exact same shape horizontally symmetric? Turn it to the side, right? So if I did this, when I fold it horizontally, now it's horizontally symmetric. Okay, make sense? There are other types of graphs that can have vertical or horizontal symmetry. These are just two examples. Those U-shaped graphs can also have horizontal and vertical symmetry. And even some of the straight lines, those constant graphs, can have symmetry as well. Okay? So with our Cornell notes, we always end the notes with a summary, and the summary should answer that essential question at the top that you wrote. So here's the summary that I wrote answering that essential question. And because this is the very first day, I did it for you. Next time, we'll do it together, and then I'll have you start practicing it by yourself. So, summary. You read graphs from left to right, which helps you determine if the graph is always increasing, decreasing, or constant. If it is none of those things, the graph must have an absolute minimum or maximum. A graph has symmetry if it is the same on both sides when you fold the graph in half. If there are no breaks in the graph, it is continuous, and if it is made up of points, it is discrete.